So, in this hydraulical part, we have two cylinders. Here, we have two cylinders.
Yes.
And be attentive. Come here closer. These type of pumps, there are two types of pumps, bilateral or unilateral. The same name, double-sided or single-sided, or we call them triplex and duplex. What does it mean? Unilateral or bilateral? No, bilateral or double-sided. This one. What does it mean? You see the cylinder here in the hydraulical part. You see the rod here. The rod.
Yeah.
Yes. On this rod we have the piston. Yes?
Yes.
The piston moves inside this chamber, inside this cylinder. And we have the inlet valves, outlet valves. Inlet valves, outlet valves. And in this moment is important. This kind of pumps, it works double-sided. Just imagine if the rod goes to the left, the mud which is in this chamber, it goes through the outlet valve. The same time, next portion of mud goes to the right chamber. It goes simultaneously. It goes here and this goes there. When it goes to the left, the mud goes through the outlet and the next portion goes through the inlet valve. When it goes to the right, we have quite opposite picture. The mud which is in this chamber, it goes through the outlet valves to the line. And the next portion, it goes to this chamber. So one piston, it works like two pistons. To here and to there, to here and to there. It's this way of work we call double-sided, or this way of work we call it bilateral, B2, or we call them also duplex. As usual, not as usual, but always, this type of drill pumps, it has two rods and two pistons and two cylinders. And two cylinders, they work like four cylinders, yes?
Four.
We have two of them, but each of them, it works double-sided. So, in fact, we have four working chambers. This idea, is it clear for you?
Yes.
This is one type. Another type, which is very popular nowadays, is one-sided or unilateral, or unilateral, or as usual we call them triplex. But why we call them triplex? Because as usual they have three rods, not two like this one, but three rods, and they have only one working chamber. Only this chamber is working. This doesn't work.
Doesn't exist.
Yes, this is the difference between these two. This part works, this part doesn't work. So they don't have these valves, they don't have this pipe, only this chamber works. Nowadays, very popular, this single-sided or triplex or unilateral pumps with 3 or 4 rods. But only one chamber is working, this way. Is it clear? Yes. So this is the main difference between these two types of the pumps. It's for you to understand because
I didn't after the pistons, because of the piston, that's why they are two.
pistons are here inside.
That's why they are two. Like cordon bilateral.
Yes, bilateral,
Because
there are two rods, two pistons, and every piston in every chamber. In one cylinder we have two working chambers, this one and this one. When we suck some here, we push from there, and vice versa. Будь здоров. So, Олег Йосифович,
Крона is coming.
Йосифович, насос можна на хвилинку включити?
You got Corona?
Я включу, просто можна включити.
Go to China.
Ні, я просто питаю, чи нічого там не розібрано, це щеплення.
Don't you switch it?
one-sided nowadays they're a little bit more popular. I can not say that we don't use this. I don't know how they did manage it, but the engineers do it in the way that these triplex, one side pipes, they need less material and they are lighter. I don't know why. I have to look through papers, but it's. So here in this case we just pump water from here to there. One more or two more important question. Here, what should be here?
Klein.
Here.
Air?
No. You see the water goes through this pipe, through the inlet valves, then through the chamber, then through the outlet valves to the line, and in this line it goes to this tank. This one, what is it for?
To spray the water?
Here always,
For recycle.
here should be the safety valve. Security, safety valve. If something goes wrong here we have the very thin bronze, how to say, plate.
To fix it.
Yes, if something is wrong, this bronze plate is broken and the water will go to the initial tank. Every pump is very important. Every pump it has its own security or safety valve. This one is very simple here, but every pump has something like that. And another question, what is this?
Pressure for pressure. For pressure.
What for pressure?
Pressure for pistons or
It's motor.
Yes, it's for pressure, but what it does with pressure?
To
it's,
save the pressure?
no, to balance.
Yes,
to
right,
balance,
yeah,
To balance the pressure.
It's dampener, the compensator. Let's go to the blackboard. Right, yeah, but I like to explain it more wide.
Engineers. Don't do like that.
So, first of all, remind your childhood, or perhaps nowadays, when you used to ride a bicycle and you used one pump to pump the wheels of bicycle. Yes, in this case you have one cylinder. I will draw it in this way. The rod, piston, inlet valve, outlet valve. The air goes here, the air goes out from there. Only one cylinder. When your handle goes back, if I draw a line, here we have pressure, time. When the handle goes to the right, the pressure rises, yes? When it goes back, we have nothing. The one portion of pressure, nothing. One portion of pressure, nothing. Yes?
Yep.
Is it clear?
Yes, sir.
If we have two cylinders, or we have one double-sided cylinder, this way, the same, we will have something like that. Yes?
Yes.
Am I right?
Yes, sir.
Is it understandable? If you have 3, 4, or double-sided or something like that, different variants, you will have something like. Yes? Is it clear?
Yes.
But nevertheless, on the top you will have this pulsation. And this pulsation, this difference, it's very bad. Why? Because in our drill rig, everything is vibrating. The motors, engines are vibrating, the rotary table vibrating, the drum it has on vibration. We have this pulsation in the pumps, in the pipes, and one time more, switch on your imagination. We speak about the pulsation of great pressure. It's not like here, it's a great pressure pulsation, and it's very bad for connections, for pipes, for all the equipment. It's very bad. That's why we have to look how we can make this line as smooth as possible. There are a lot of types of these dampeners, but nowadays this spheric dampener is used almost everywhere. It's rather good. According to the calculation, to make the straight line without pulsation, we need the infinitive diameter. But this one is rather okay. How does it work? We have the chamber, which is divided to two parts. On the top, we have a rubber chamber like this one. You see it?
This one?
Yes, this one.
What will be inside it?
It's here. It should be filled by a nitrogen. The best way is nitrogen or the air. As usual, very often it's just the air. By the way, it's much more nitrogen in the air than the oxygen.
Yes.
It's common to us to say that we are breathing by the oxygen, but the real situation is that it's much more nitrogen than oxygen. So the best way is to use it by nitrogen, because the nitrogen is completely inert. It's safe. It's not flammable. So it's the best way is to fill it by the nitrogen, but very often it is used to fill it by the just an air. So here we have the pressure. Here we have the line, and this is filled by the mud, drill mud, or water as it was. And what do we have? If we have the maximum of the pressure, this will be deformed. When we have the minimum of the pressure, this rubber chamber will be deformed this way. It's like a spring in your car. When you used to drive a car, you have the wheel, yes?
Yes.
If you have the heel here, the spring will be deformed. If you will have the hole here, the spring will be deformed. And in your car is almost straight, almost. Not completely, but almost. Here we have the same situation. If we have the maximum of the pressure of the drill mud, this chamber will eat this pressure. If we have the minimum of pressure, this chamber will, like a spring, it will help. And finally, we have no the straight line, but we have something like that. And it's enough. What should I say to you else about the pumps? Let's go through them. So here we have the parts we spoke there, rod and the piston. Someone asked what is the piston. So this is the piston, this is the rod. Here we have the cylinders. Remember it forever and also. Nice. So, every pump has two main parameters. The one parameter is the pressure, or it also says us how high we can move our liquid, and the other parameter is the production of them, how much. These two parameters, they have special connection. If the pressure is higher, the productivity is smaller, and vice versa. So it is about all the pumps. Later, while speaking about the production equipment, we will also speak about the pumps, and we will also speak about these two main parameters. So you have to remember it forever. And how to change the flow rate or the productivity of this type of pump. How to make it move more or less liquid.
It's about the valves. You have valves or not?
No, the valves only open, close, open, close. The valves let the liquid to move in one way.
Okay.
To move it one way, not go back to this pipe. That's why we need the valves.
What's the
How to change the parameters of this pump?
from the speed of motor?
Yes, it's possible to change the speed of the motor, but as usual, it's not so comfortable because you know that, for example, in the cars, it is recommended the rotations per minute. The same here, every motor, it has recommended rotations per minute. So certainly you can be from 2000, for example, to 3000, but it will be problem if you will try to use 5000 or 7000 rotations per minute. So it's right here, it's possible, but it's not comfortable every time. How else to do it?
From the pressure?
How we can change, how we can make this pump to move less or small liquid.
Mechanic?
Hydraulic.
From hydraulic?
Yes. You see this hydraulic box or hydraulic part, all the names are correct. Sometimes they say hydraulic box. It can be opened from this side. From this side. These covers can be taken off and we can open. And that's how we can change the cylinders inside it. We can put smaller or bigger cylinders with smaller or bigger diameters. That's how we can change the parameter of the pump. If we put the cylinders with smaller diameters, we will have smaller flow rate, smaller production, but we will have bigger pressure.
Always we should like if we have like problem in the pressure, we should to change this. It's in fact.
If we you see that this hydraulic box is done in the way that it can be opened in different places. For example, it's very easy to open this box with the valves. It's easy to open this hole with the cylinder. So these geophysics pumps, the big ones, are done in this way that it's comparatively easy to open any place of the box and to change the valve, to change the cylinder, to repair something if we have some problems. For beginning to return this question of the regulation, you have one thermometer switch on your imagination. We are drilling for 100 and 1000 of the meters. It's not like a car that you drive and every second you change something to change the speed, to change the direction, to change the rotations per minute, up, down. So we calculated that we need this performance, we need this flow rate. We will need this flow rate, for example, for 1 kilometer of our drilling. So we changed these cylinders, we put them in this place, and if we need the little regulation, we can use your method to change the rotations per minute on the motor. But general regulation is here.
So say you said if you want to regulate your flow rate, you insert a smaller cylinder. Then the parameters will increase.
One will increase, one will
Would decrease.
decrease.
Then it will increase the pressure. The smaller one will increase the pressure.
Yes, if I put smaller cylinder,
Cylinder.
I will have a smaller amount of the liquid, but I will have bigger pressure.
Pressure.
If I put bigger
Bigger
one, I will have bigger amount but smaller pressure.
Pressure. Okay. So that's how you read the flow rate
Yes,
from the hydraulic side.
yes, these two parameters are connected for every pump. We have the diagram of the connection, even in laboratory work that I am going to give it to you. It is on the picture,
Okay.
this graph. That's about all. If you have some question, you're welcome.